So here we are, 4.1c. One of the things that is important about this lesson is I showed you how to, just real quickly, how to graph the two equations and look and see where they cross on the graph, and then you can determine your x and y value, that point that they cross. I also showed you the addition method, which I grew up calling it the elimination method, and maybe that's what you've heard it called before. And then we get to this one, which is called the substitution method. Substitution method and the addition method that we just did are two different ways to solve these systems of equations. They both work all the time. But sometimes one method is easier than another depending on the problem that they give you. So it could be that the system of equations they give you, the best way to do this is the addition method. Could be they give you another one. The best way to solve it is the substitution method. It doesn't matter which way you solve it, it will be correct. It's just like I say, sometimes one of the methods is easier than the other. So let's look at the substitution method. And when I was learning this stuff, they always taught you the substitution method first, and then they went to the elimination method, and now they're going the other way around, which I think is the better way of doing it. Okay, I'm going to get rid of this 6 and make it better. Okay, so notice we're not stacked. We don't have our x on top of each other, our y's on top of each other, and our numbers on top of each other. They're just kind of in weird places. Okay, doesn't really matter. I could move everything around so that everything worked. Like I could rewrite this as 2x minus 3y equals negative 6, negative 3x plus y equals negative 5. So see, I just took this 3x, subtracted it from both sides, and put it over here. So now I'm stacked, and I can use my addition method to solve it. This is where the substitution method comes in. When I have a y all by itself on one side, and it equals a bunch of other stuff, this is where the substitution method can be helpful. Because what does this say? This says that y equals this. So both of these are the same and can be used interchangeably. So what I'm going to do is I'm going to look at the top equation, and instead of putting a y in, I can put a 3x minus 5 in, because they're the same thing. They're equal to each other, it says right here. So I can do that. And look what happens when I do that. My y is gone, and all I have are x's, which means I can solve for x. My wife is over there playing Christmas music in early November. Okay, so those go away. That ends up being negative 21, so x ends up being 3. I didn't have to do anything with elimination or anything weird. I just did that. Now I need to find the y value. Remember, you have to find the y value. So I'm going to take my 3 here, and I'm going to put it in there. So y then equals 4. So my answer is going to be 3, 4. And that's the substitution. They call it substitution because they're taking what y is here and substituting its other equality, its other equal statement here, and putting that in there. Because when you put that in there, you're taking an x and putting it there. So now you have one equation with one variable. It makes life so much easier. Okay, let's try one more, and then we'll be done with this lesson. All right, so let's take 2x plus 3y equals 5. X minus 2y equals 6. Now notice that my variables are stacked upon one another, which means, oh, this would be easy to multiply this bottom by -2 and make this -2x plus 4y equals -12. I can add these go away, and so it's the addition method. But the problem is, example 8 says use the substitution method. So remember, in the substitution method on the last one, I had 2x minus 3y equals -6, and then I said y equals 3x minus 5. So one of the equations had the variable isolated or by itself. That has to be the case in order to use the substitution method. So let's go ahead and isolate the x. Let's plus the 2y to both sides. Why did I put a 6 there? So this is the same as this. So now I can look at my top equation, and wherever I see an x, I can put that in its place. And then I'll add my 3y equals 5. Now notice, all I have are y's there now. My x disappeared. Add those two. Okay, subtract 12. So 7. 5 minus 12 is -7. So y is going to equal -1. Now I can take this -1 and I can put it back up into, well, let's put it back up into this one. So taking our equation, x equals 2y plus 6. I know there's a -1 here. And keep going. X equals -2 plus 6. X equals 4. So my answer then is 4. My first number is my x. My second number is my y. And there we go. So that is 4.1.